Hello, my name is Nick Clute. I'm a business development manager with Turck, and today I have a very interesting application. I have a Zimmer gripper on IO link, and I'm going to show how we can communicate to that using the Turck IO link block, and also how to set it up with an Allen Bradley and use a little add-on instruction that we threw together to make the process data a little bit more manageable. Out of the box, I've got my Turck IO Link Master here, and you'll notice, first off, you've got a lot of red lights, a lot of green lights, and a blinking red and green light. So, by default, all IO Link channels are configured to communicate to a device. And when it's not communicating to a device, it's considered an error. So it's got all red lights. Because all of these ports are empty, it's expecting an IO Link device, and there's no IO Link there except for the one that my gripper is plugged into. You've got 4 green lights on the right hand side. That is our Class B power. So this gripper is actually a Class B powered device so that you can safely shut off the output power to it while still maintaining the communication through the Class A side. The other thing you'll notice is that bus LED blinking red and green. So out of the box, we come as PGM DHCP mode. And what that means is we are going to respond to just about every method that we have to communicate IP addresses. So we'll do DHCP, we'll do bootp, we'll do static IP addressing, we'll do Profi naming. And in this mode, before we've officially received an IP address, we will not allow PLC communication. Our default IP address is 192.168.1.254. If we use our Turck service tool here and we scan for the device, we find it. It says 0000 because we really don't want you to use that. So we hit change, and you can see that the actual address is 192.168.1.254. I'm going to set that to .100 just as a for instance. When I set that, that bus LED is going to go to blinking green, indicating that it has an IP address and it's ready for PLC communication. So, not required, but the next thing that I like to do when I get a brand new IO Link device is I open up our web server. This allows me to actually go out to the web and find the IO Link device and the device parameters using the IODD file. So we're going to go to IODD configurator. We're going to log in with password, all lowercase. And you can change that if you need more security for your application. It's going to, right now it's communicating to the device itself. It found that it's a Zimmer device, a GED 6000IL. I can go over here to web search. And then what it's going to do is it's going to go out to the IO Link Consortium webpage database. It finds this exact device and it pulls all of this information available. From here you can go through and you can look at and change parameters. You can view offline, or you can view acyclic diagnostics, and then you can also view the process data, which is probably one of the most important things that I like using. So here you can see all of this, but we're going to go process data. That's going to be the most important thing. So status word is 34,889, diagnosis is 768, and actual position is 99. All right, so from here, let's go ahead and jump into our Allen Bradley. So in Allen Bradley, what we do to try to make our IO blocks as easy as possible to work with is we can either use EDS files or generic devices. We like using generic because a lot of places nowadays are using that for because of version control issues with EDS files. Plus we get a little bit more flexibility with them. The problem with generic devices is, like an IO Link device, it has like 173 words, and how do you find all that data? So what we've done is we've created an Allen Bradley project that has all of our IO blocks built in. We've got one for our standard blocks and we've got one for our safety blocks. And what we've done is we've gone through and we've set up all of the class instances necessary. We've set up all the sizes, and then we've also named all of the controller tags. Allen Bradley allows you to drag a device from one project to another project, and I've already gone ahead and done that in order to save us a little bit of time. But you can just click on here, drag it into your project, and then what it's going to do is it's going to carry with it all of the parameters necessary. So then the next thing that we do is we can set this to a custom name. All right, so we're going to call this Gripper IO Link, right? It's already got the assembly instances and the sizes, and then we set the IP address. So I already set mine to 100, which we know from the Turck service tool, and that's it. Technically from there, I could communicate to this device, no problem. But we're going to go one step further. So an IO Link device has specific settings inside of it in order to change how different IO Link ports work. And what we do is we actually expose this information into the C data, okay? So specifically in this case, I want those red lights to go away. So I'm going to take the operation mode for each one of these devices. And if I go over here, what I'm going to do is I'm going to turn it into a digital input. And so in order to do that, I need it to be 1000. So 1000, so that's a hex 8. So this port 1 has already been disabled in this application. Let's go ahead and check the other ones and see. So port 2 has not, so I'm going to paste DI, port 3, and then my gripper here is on port 6. So we're going to skip that one. Port 5. Oh, not data storage mode. I don't want to change that. I don't think it matters if it's disabled. Okay, port 6 we're going to jump over. Port 7, disable that one. And then our last one, port 8. Okay, so now the next thing that I'm going to do is I'm going to bring in, I've got this Zimmer gripper add-on instruction available. So I'm going to create a new thing here. I'm going to Alt insert a new element. I'm going to do a CPS because I'm going to copy in the process data from the controller tags. I am then going to do another Alt insert. We're going to add in a Zimmer gripper block, and then we're going to do another Alt insert and do a CPS for our process data in. Okay, so now our source. All right, so if we go back to the controller tags, and again, this is why we use the catalog file, is that we go back to the source, we can open up our iData, and it doesn't take but a little bit of scrolling to find exactly where the port 6 process data begins. Right? And then at the top you have all of your standard data, including things like if you are using these ports as digital inputs, then you can grab those specific bits, or if you have aux control enabled or something like that. So my input data is on 83. I'm going to call this test gripper process data input. Length is 1 because I only need it to be when I create that size. Okay, so that data type, okay, is over here. Process data in is going to be a type of generic 3 words, and then process data out is going to be generic 16 bytes. So I'm going to take this, I'm going to say test gripper process data out, and then we're going to paste that back. I know that the Turck output data is 1 off from the input data, so it'll save us a trip into the controller tags. And then this is going to be 16 bytes, which is 8 words. The Turck data is done in 8, and the CPS command is done by the length of the number of units of the destination. So the destination is a word. I need it to be 8 words to get 16 bytes. Now with the AOI, what I'm going to do is I'm going to create a instance of this called test gripper. My process data in is going to be from this one. My process data out is going to be from this one. Now here's where the magic happens, right? So this is done. All we need to do is declare it. So I'm going to go ahead and highlight over test gripper, Control W. It'll automatically know that I'm trying to get a data type of the AOI. We'll create that. Then we'll go to the PDI, process data input Okay, let the virtual machine catch up just a little bit. All right, and then we're going to Control W that. It knows that it needs generic 3 words. We're going to go on the PDO. We're going to Control W that. It knows it's generic 16 bytes. And all of our errors are going to go away as soon as that gets created. Look at that. So now we're done. Once I download this, then what we're going to see is we're going to see this bus LED go solid green when Ethernet IP communication has been established. We're going to see all of the red lights turned off because of the controller tags that get pushed down to it. And then we're going to have all of our Zimmer gripper specific information get loaded into this AOI, which is being copied from the controller tags, and then all of the information that you give it in order to move the gripper is then going to get copied back out into the output controller tags. So this gripper itself is a little bit interesting. What we're going to be seeing is we're going to be looking at this error. We're going to be working with the data transfer bit in order to tell it what it is. We're going to be also changing the device mode in order to get it to go what we're going to do. And then once we get it into the proper device mode with the motor on and everything's happy, all we're going to do is we're going to turn on move to base or move to work, and we're going to see these gripper fingers move to those specific positions based on the speed at which we will do that. So Allen Bradley is taking its sweet time. Apparently it's a little bit slower when you're on record. Okay, so the next thing it's going to do is it's going to pop up and ask me if I want to go back into remote run, or am I going to have to click? Alright, here we are. So now we're in remote run. As you can see, we are homed okay. We're not moving. The gripper PLC is active. What that means is the gripper communication to the PLC, or basically the I/O link, is active, and our error is active, as we would kind of expect. And then our actual position, I don't know if I can move this manually. Yeah, so if I move that manually, you can see the actual position change. All right, so let's put in, so what they recommend is they recommend a position tolerance of 50. Grip force 50. Drive velocity 50. Base position 100. Shift position 1000. Teach position 3000. Work position 3000. Okay, so the next thing we're going to do is this motor on. We need to get that turned on. So that's device mode 3. Okay. And before I do data transfer, let's just do a sanity check. Let's double check to make sure that those data is actually getting through the Ethernet IP into the I/O block and being sent to the gripper properly. And we do that by going ahead and checking the process data, and all of these are the same. And we can actually see that that's correct. I can change the position tolerance here to 52. That sounds good. And then we will jump back to the web server and we should see 52. There we go, 52. So that's great. So then what we'll do is we're going to do a data transfer. And we should see data transfer OK turn on. There we go. Motor is on, which is what we needed for the device mode. So we're going to go ahead and turn off data transfer. We're going to turn on device mode 50. We're going to get an error. It's going to be 774. That just means that there's been a change in the values that has not been transferred properly. Do a handshake. Okay, so we do data transfer to 1, data transfer to 0, data transfer OK. Now we've got motor on and we've got no error. So now if we move to our work position, we grip. And if we move to our base position, we ungrip. Just that easy. So we will have this Zimmer gripper AOI somewhere in the video description, or just request it from Turck, or you might be able to also find it on our website. Any other questions, please feel free to reach out. Oh, I just noticed that I have a port 8 error. Did I put that on the wrong controller tag? Let's take a quick look, just because I'm curious. Go to monitor tags, change the C data, scroll down to, wait, is that I data? Expand out the C data. All right, go back to, so inside of the C data, as I'm scrolling, one of the things you'll notice is that all of these settings are all the settings you would normally set through like a web server. But by using the controller tags, what we can do is we can set all of these right from the PLC program, which means that if you ever have to do a block replacement, all of those settings are set within here, as opposed to in the block itself. So anytime this connects, all of those parameters are going to be sent down. So yeah, I did miss port 8 operation mode. I wonder where I pasted. Did I just stop at 7? I must have stopped at 7. So what we can do is we'll show that if I change this to 8, nothing's going to happen, right? Because these controller tags are sent down upon communication establishment. And so I can either, one of the easiest ways actually is I can just pull the Ethernet cable and reconnect it. I could also pull the power and reconnect it, or I could inhibit it and uninhibit it from the Allen-Bradley process. So what I've got going on here is I can go ahead and change that. And then once that gets connected, then we should see that red light go away, right? So let's go ahead and disconnect this. Solid green. And then don't tell me that my controller tag didn't take. Oh, I didn't hit enter. Okay. Go ahead and try this again. There it goes. All right. So that has been the Zimmer gripper with the Turck IO Link Master. If you have any questions, again, please feel free to reach out. Again, my name is Nick Clute. And my email is nick.clute, C-L-U-T-E, @turck, Turck.com. Have a good one.